let's talk about vectors. So Unit 15, Day 3. Again, there wasn't a Day 2 video. I was out, and there was nothing new to do anyway. So Day 2, there's a worksheet, but not a video. Day 3, there's notes and a worksheet. Vectors, Part 1. Vector. Very rarely do we ask you to give a definition, but this is one of those times where in fact, I don't know that we ever ask you for a definition, but this is one of the times where we will ask you for a definition. A vector is a quantity with two words. You've seen Despicable Me. What are the two words that go with vector?
Oh, yeah.
Magnitude and direction. And every year someone wants to watch the whole movie just so we can see that one scene. And the answer every year is no. Go watch it on your own if it's that important to you. It will really enhance your learning experience. Go watch it. Vector, a quantity with magnitude and direction. Magnitude isn't always length, but it's usually length, like how long the vector is. Direction wouldn't have to be given with an angle, but it's usually given with an angle. Like you could say 50 pounds north as a force vector. So that wouldn't really be an angle, but it does have a direction. So angle isn't always the case. It's not always length, but for us it's almost always length and angle. All right, we're going to do a little bit of drawing and a little bit of algebra. So the first part is drawing these. Physics, did you draw vectors in physics? Okay, it's the same way, although it's a little bit easier in here. It's still the same process, I guess, concept, tip to tail. But in physics, when you draw them, usually you're with a ruler and a compass or a protractor, and you're trying to be super accurate. Here, it's more about the concept than the accuracy. So I'm not going to get out a ruler and measure. It's just more of, did you get the tip to tail thing right? So start with vectors A and B. We're basically eyeballing it. So the question was, what if we don't know? We don't know the angle. Like, well, how steep is A? For us, we're just eyeballing it.
So just 45 and 180.
45 and 180, sure.
Okay. So how would this be tested then?
We'll have you draw it. Actually draw it. The test. The question was, how will it be tested? Like we will grade your drawings.
Oh, okay.
Not like with a ruler, but it better look like it's supposed to look.
It's 60 degrees.
You can't have a 30 degrees 60.
So I'll do some bad ones to show you. So A plus B. Vectors are like following directions. That means go A and then go B. So there's A. And the big thing is to put the start of B at the end of A, just like you're following directions. If I tell you how to get to my house, you don't go back to the starting point every time and go, each step. You take the next step from where you land. So you go A, and then from the end of A, we'll put B on the end of that. And then, so that's sort of A plus B, but if we leave that, that's like asking, if I ask you to add 2 plus 4, or 2 and 4, and you said, okay, I can add 2 and 4, the answer is 2 plus 4. Like, well, yes, but I need you to give me the answer. And so this is the picture of A plus B, But the answer is you started at A and you ended at B.
A, B, 2.
And so that is, you can either call it R for the resultant, or you could just label it A plus B. You have to have an arrow on there, and it doesn't make a circle. So some people, they put the arrow going back toward the finish. It's like, oh, I completed the loop. No, it's not a loop. You started here, and you ended here, so your arrow goes from start to finish. So again, make sure you draw the answer, label the answer with the correct answer, or with the correct direction on the arrow. So what would be wrong, like wrong answers? A common wrong answer would be this, but that's not how you follow directions. You don't go back to the start every time, so that's not right. Like how accurate do you have to be? I mean, if your A is that long and your B is that long, like, well, no, that's not even close, right? The starting picture was B is about twice as long as A. So if you're drawing this, you're not even in the ballpark. So I'm not getting a ruler out, but if I can tell by looking that you're off, then I'm going to take some points off. So again, you don't have to use a ruler, but you do have to engage the brain. Like B is longer than A, so make your picture, as close as you can, match what it's supposed to match. All right, 2A minus B. So that means we'll draw two A's back to back, and then we'll do the negative of B. Another way that helps some people think of it is, since we don't really add vectors, since we don't subtract vectors, we could add a negative B. And a negative B would just be going the opposite direction. So there's A. Again, not with a ruler, not with a protractor, but those look the same to me. And another A. 2A. And then how am I going to draw minus B? Which way is?
To the left.
It's going to be to the left. Some people, it helps them to draw the negative one right underneath or next to the positive one. So there's negative B. So I'm going to go two A's and then a negative B. Again, the link doesn't have to be perfect, but it needs to be in the ballpark. So 2A and then negative B. And again, that picture is, if I ask you to take 2A and subtract B, and you tell me, okay, 2A minus B. Like, well, yes, but what's the answer? The answer is the picture from start to finish. So there's 2A minus B. Or you can just call it R for the resultant. And this is really one where you have to show your work. You can't, even if you could sort of visualize it, I don't want to just see that resultant as an answer. I need to see the process of you drawing two A's and then a negative B. Why don't you try this one? B minus 2A. So draw B, and then draw two negative A's back to back. See where you land. So draw B. Negative A is the opposite of A, so just go in the opposite direction. So the arrow is just on the other end. Negative A. And another negative A. So from start to finish, there's my resultant. Again, you have to have an arrowhead on there, and it's got to be going the right way. You will lose points if you do not put the arrow on there. Say that every year, and every year somebody's not paying attention through all of the examples, and the answer doesn't have an arrowhead on it. I can't give you full credit if you don't tell me direction, right? Magnitude is the length, and the little arrow tells me which direction it's going. All right, so it's the same thing you did in physics, But in physics, you got out rulers and protractors, and we're more accurate. Here, we're not so concerned about the accuracy. It's more about the concept. Put it in the right spot. All right, that's the drawing part. Next comes the algebra part. So let's say vector A is, and there's a couple ways to write vectors, so we're going to kind of see that on the fly here. 3, -2 with little brackets, but not square brackets, like, what do you call those? I don't know, arrow brackets? Not parentheses, because that'd be an ordered pair. So 3, -2. Let's say vector B is -1, 2. And we're going to have a vector C, but let's pause here and see. What this means is, so it looks kind of like an ordered pair, and it kind of works like an ordered pair, where the x component is first and the y component is second. Again, this kind of matches with physics, where you break a vector down into the x piece and the y piece. So this means our vector goes 3x direction and 2y direction. So +3. So wherever we start, we'd go right 3 and down 2. And so there's vector A. Right 3 and down 2. Vector B would be left 1 and up 2. Left 1, up 2. For vector B. Vector C, I'm going to use a little bit different notation. 2i plus 3j. It means exactly the same thing as 2, 3. And so some people like the ordered pair notation, other people like the ij notation. It doesn't matter. And they're so close that if you give an answer in either form, it doesn't matter to me. And so every year there's 1 or 2 people who convert everything to ordered pairs, 1 or 2 people who convert everything to ij. Most of the people just kind of roll with what's given because they're so close. It's not really that difficult to keep up with. Let's draw C. So that would be 2 to the right and 3 up. So 1, 2 to the right and 3 up for vector C. Now that, I guess that's still part of drawing. Maybe I should have included that in the drawing section. The more algebra section is adding them, but not with a picture, but by their components. So A plus B, that means 3, -2, because that's A, plus -1, 2, that's B. And then this is part of why we include it with the matrix stuff. Part of it is they're both really easy, so it's an easy thing to combine and make one unit out of. But the other reason is these act a lot like matrices. So when you add matrices, you add the pieces. So if I add the x pieces, I get 2. And if I add the y pieces, I get 0. So my answer is 2, 0. So we could add A and B graphically with a picture, or we could add it algebraically, add the x's, add the y's. Let's try 2c minus 3b. So 2 times 2i plus 3j minus 3 times -1, 2. I'm going to show a lot of steps. A lot of you are not going to show many steps, or maybe even any steps. That's okay, but there's a lot of things going on here, so be careful. If you're going to be a a step skipper.
Where the fuck a personal attack?
So I'm going to distribute the 2, 4i plus 6j. I'm also leaving them both as they're given. Like, if you don't like that mixed format thing, you could switch them to one of them. Switch this one to ordered pairs, or switch that one to IJ and make a match. Or you can just roll with it as they are. It doesn't matter. If I distribute the -3, here's where we need to be careful. Then I get 3 -6 because I distributed the negative. But that's now a plus because we took the minus sign. We've already used the minus sign. I guess the other thing is you could distribute the 3 and leave the minus sign. But eventually you've got to consider that negative sign going to both of them. All right, now it's a little bit weird because we're adding an IJ notation with a ordered pair notation, but it's the same idea. Add the x's. 4 plus 3 is 7. And I guess I have to make a decision here. Do you want IJ or do you want ordered pairs? Ordered pairs it is. It doesn't matter. We'll go ordered pairs. 6 minus 6 is 0. So I put a 0 there. So there's my answer as an ordered pair. If you preferred the IJ notation, that would be 7i, 7i. You could put plus 0j if you wanted to. I don't know how to make it like sort of optional. The ghost form. You can put a 0j if you like. It sort of emphasizes that it doesn't have a y component. But because it's 0, it's also okay if it's not there. So that's like 3 different correct answers there. Ordered pair 7, 0, 7i, or 7i plus 0j. And there's not even a preferred form. It's whatever you like best. They're so close that it's not difficult for me to grade. As long as you got one of those 3 things, you'll be fine. All right, the last part of the algebra piece is finding the norm or magnitude or length. It's the same thing. How long the vector is. The symbol for it is 2 bars on either side of whatever vector we're trying to find the norm of, or the magnitude of. So that means find the norm of A, or the magnitude of A, or maybe best of all, the length of A. And we're still using the same A, so that was 3, -2. So the length of 3, -2. Well, if you think back to what this meant, it's not a difficult formula to figure out. 3, -2 meant our vector went 3 to the right and 2 down. There's vector A. Especially if I throw a right angle in there. So how can we find the length of A? Pythagorean theorem. A squared plus B squared equals C squared. So it's a formula you already know. Some notation you don't, with the 2 bars, and words you maybe not, norm and magnitude. But once you understand what's being asked, yeah, it's just A squared plus B squared equals C squared. So 9 plus 4 is 13. Square root of 13. And then really, since now you know what it is, you don't have to draw a picture every time. The picture helps you remember the formula, but if you just look at that and think, oh yeah, it's A squared plus B squared, you don't have to draw the picture. Let's find the norm of 2c minus b. Now, that's 2c minus b is in the norm bars or the magnitude bars, so I need to do 2c minus b first. then we'll do the norm, as opposed to, right, this is not the same thing as the norm of 2c minus the norm of b. So I need to do the math first, and then I'll do the Pythagorean theorem. So 2 times 2i plus 3j minus negative 1, 2. Again, with the mismatch notation, which if that bugs you, it probably should bug you a little bit. If it bugs you enough to change it, you're welcome to. If you're fine dealing with it, that's also fine. Here's where we can maybe skip a step if we want to pretend to be Will for a moment. Dangerous game. Nobody wants to do that, really. But here's how you would skip a step. You know that you're going to distribute the 2 and add the x stuff. So let's see if we can do this. 2 times 2, and then what do I do with that 1? Plus 1. So 4 plus 1 would be 5. And then the y piece, or the j piece, the second coordinate. Again, I'm doing a lot of steps at once. None of them are that hard. It's just be careful. 2 times 3 is 6. Minus 2 is 4. So 2c minus b is 5, 4. And then now I want the length of 5, 4. So there's just a lot of steps to this problem. None of them particularly hard, just a lot of steps. I don't need to draw the picture. I know that this means 5 right and 4 up. So this represents kind of how to build the triangle. A squared plus b squared. So 25 plus 16 is 41. So the length of 2c minus b is square root of 41. Why is that different than what I had in my notes? What did I do wrong? Which one is wrong? Oh, my notes were wrong, so this is right. All right, last example. The length of 2, 1, negative 3. So that's not really an ordered pair anymore. It's an ordered triple. But it works the same way. And this is hard to draw because it would be 3 dimensions, right? It would be 2 right, 1 up, and negative 3 out, or I guess 3 into the page. But the math all works that it's the same thing. It's still the square root of a squared plus b squared plus c squared. And that's not just a vector thing. It actually works in real life. Like the length of a diagonal of a box is a squared plus b squared plus c squared. 4 plus 1 plus 9 would be 14. I added that last example from previous years because I don't know why I didn't have it in previous years, but when people get to the 3-dimensional stuff, panic ensues. It's like, no, it's the same thing. It's still the square root of the sum of the squares. Did I say that right? The square root of the sum of the squares, yeah. All right, worksheet 3 is the assignment. Answers are posted. Again, not real difficult, but important to get the practice in. And then we'll add one more thing tomorrow. We'll review on Wednesday. We'll test on Thursday. And then we'll have a long weekend.